Today we're looking at what happens if we already know that triangles are similar or we can prove them, and we wanted to go a little bit further than that. So we're looking at congruence and proportion in similar triangles. So if triangles are similar, that means that two things must be true. Corresponding angles must be congruent, and corresponding sides must be proportional. As a quick reminder, proportional means that the ratio of the sides is equal. So if I pick any pair of corresponding sides in one triangle, they have to be they have the same ratio as any other pair of corresponding sides in the same two triangles. Now we have CP/CTC. We used that back in chapter 3 when we proved triangles congruent. And after we proved triangles congruent, we could pick out the parts. And CP/CTC stood for corresponding parts of congruent triangles are congruent. Now CASTC and CSSTP are the same basic idea. Once you know something, you can start picking out the parts that you need. But instead of having congruent triangles, we're looking at similar triangles. So just like CP/CTC, the first letter C stands for corresponding. The A in this stands for angles. So corresponding angles of, instead of congruent triangles, similar triangles. And if triangles are similar, that means that the corresponding angles must be congruent. Now again, if you want to know the shortcut, great. If you want to use the actual statement of it that similar triangles have congruent corresponding angles or something to that effect, that works too. Now on the other side we have CSSTP, which involves not angles but sides. So the second S stands for similar, and then triangles again. But instead of the sides being congruent, they're proportional. The ratios of the corresponding sides are the same. So CSSTP, and just like CASTC, if you want to know the shortcut, great. If you want to just say if triangles are similar, then corresponding sides are proportional, that works too. Alright, so example number 1, we are given that CB over EB is equal to BA over BL. What that tells me is that I have two sides that have the same ratio. So these are sides, and because the ratios are equal, that means that they are proportional. So what I'm looking for then, if I look at CB and EB, here's one pair of sides, and then I've got another one here, BA and BL. I'm looking for the angle that's between these. So it looks like we're going to pick this angle and this angle, and I want to know how do we get those congruent. Looks like it's from this second given that CB is perpendicular to AL. Thinking back all the way from chapter 1, we know that if lines are perpendicular, they're going to form right angles. So we're going to start off our proof by saying that angle CBA and angle CBL are right angles. And that's because perpendicular forms right angles. Now, if we know that they're right angles, we also know they're congruent. Oops, not triangle. Alright, let's fix that. There we go. So angle CBA is congruent to angle CBL. All right angles are congruent. So if those angles are congruent and the sides on either side of those angles are proportional, then what that means is that the triangles are similar. So triangle CBA is similar to triangle CBL. And I know that because the sides are proportional, the angle between them is the same, so it's SAS, similarity. And then in my final step, because I know the triangles are similar, I can pick out the parts that I need that correspond. I'm trying to show that angles are congruent. So angle A must be congruent to angle L, and that's because of corresponding angles of similar triangles are congruent. Alright, so again, you might need to prove the triangle similar first and then pick out the pieces. And we'll do one more example here. So in this example, we're given that angle F is congruent to angle A. Mark it up. And I want to show that FR over AR equals OR over YR. So to me, that tells me that I'm going to have to prove that the triangles are similar and then pick out a ratio for one pair of sides and a ratio for another pair of sides to make a proportion. Well, in order to prove the triangle is similar, it appears that I need another angle, and that angle is going to be that pair of angles right there, vertical angles. So in step 2, I'm going to say that angle FRO is congruent to angle ARY, and that's because of the vertical angle theorem. From there, I know that the triangles are similar, so triangle FRO similar to triangle ARY because of angle similarity. And at this point, we're on to step 4, which is the proportion. FR over OR, or sorry, let me get that set up again here. Get my eraser to fix that. It should be over AR equals OR over YR. And the reason I know that is because of corresponding sides of similar triangles are proportional.